Some.
Yes.
Would you distribute the time of your defense to the people? There's 1 minute left, but most people are online. Nobody is in real life meetings, so there may be people who are able to attend.
Sure. It's from my side, it's working. Different. Can any of the other check? No? Anthony.
I have some difficulty, but I think what I'm seeing is the past.
Okay, so do you know what's going on? You'll kill me. I think now I'm broadcasting through event to streaming, most likely.
So
I'm watching it on YouTube. Well, now it's frozen.
It's frozen, right? But if you try this one, is it this one, the previous one? I put on chat. Because I think that's... I'm still not clear when
Bernardo, I am in the previous one and I was seeing something moving, but now, no, it stopped again.
And in this one?
But I just sent the email.
And the link.
No longer members. Yeah. That's why I sent them directly.
With... So the new link is working, right?
What is the new link?
No, I put it here in the chat.
No, you sent it privately to someone.
I sent to Sirac probably. Okay, just 1 second.
You send it to everyone, Professor. It's from Bernardo Almada to everyone.
No, it says it was. Can you see now? Through chat.
I send another email.
I can. No, in my chat. If you go to that link in my chat, was that the previous one?
No, it's different.
It's different.
So I'm not sure what's happened, but every time I go live with streaming, it changes the so I will do it like this now.
This is the third link. Okay.
I'm sorry for that.
Professor, you want that I change again in the web page?
It's better. I'm not stopping now the stream, otherwise it's not converging.
This one is working.
This one is working, right? Okay, so
the last one?
Yes, please, Maria Antônia, sorry again. You can say it is my fault.
Just a minute, I will try to change.
All right. While you Sam, you can also change to your contacts, okay? The previous ones.
Sure.
This one. Okay, and while you do that, I will just start. And okay, hello everyone. Thank you all for being here at Sam's Heshmati PhD defense. It's an honor to host you in this event. First of all, I'd like to express my regards to the members of the jury especially those that come from abroad. Even though this definition of coming from abroad when we are holding an online meeting, it's somehow awkward. But thank you very much. We have Professor Charles Sox from University of Cincinnati. We have Professor Filipe Alvelos from University of Minho, and we have Professor Pedro Amorim from Faculty of Engineering, University of Porto. So these three will be the examiners of today's session. And then I would like also to say hello to the supervisors of SAM that did a great job with SAM throughout these years. Professor Grit Vandenberg from University of Leuven, and we have Professor Maria Antónia Carravilla and José Fernando Oliveira from Faculty of Engineering of Porto University. Sam, to you, congratulations for being at this stage. All the best for the next 2.5 hours, and also for our audience, the few that might be changing between YouTube channels. I messed things a little bit. Welcome you all. So the first part will be a presentation from Sam. So Sam, you have up to half an hour to present the work. And then after this part, it will follow a discussion with the members of the board. Sam, please, you may share the screen.
Okay. Okay, so I guess I have shared my screen, and I hope you're able to see it.
Exactly.
Okay. May I start, or?
You may, Sam, please.
Okay. Hello, everybody, and again, thank you for being here. Today, I'm going to talk about crane-operated warehouses and e-commerce delivery models and algorithms for theory and practice for my PhD defense. So you may all have experienced online shopping, and you may have all felt such satisfaction. But I wonder how many times you have thought about the logistics behind it or its ecological impact. Actually, these three pictures may represent my research. I studied e-commerce delivery logistics and particularly focused on environmental impact of e-commerce delivery. So my research focuses on how companies may serve their customers and make them satisfied while enhancing their efficiency and at the same time minimizing their environmental footprint. So let's zoom a little bit out and look at the role of logistic management. Nowadays, companies are trying to gain competitive advantages through logistics management, since it has a huge part of the overall operation, overall production cost. So this thesis has two main thrusts. First, integrated decision-making in warehouse scheduling, and then sustainable decision-making in e-commerce delivery. So let's see how can we enhance efficiency of warehouses by integrated decision-making. So there are mainly two decisions in the warehouse scheduling: location assignment and crane scheduling, where have been optimized separately and connected through the decision link sequentially, which this approach ignores the effect of decisions on one another and results in suboptimal solutions. So we propose an integrated approach to consider both these decisions at the same time. And in particular, we were interested in multiple crane scheduling, and we can categorize multiple crane scheduling based on the working area of the cranes into three main categories. First one is when the cranes have their own separated working area, this is not as interesting for us because it may be seen as a single crane scheduling, and it has been well studied in the literature, and also with nowadays industrial setting, it's not really realistic. Whereas we are more interested in the share working area of cranes, where cranes working area may have some overlaps, or they may share one storage area completely together. And in terms of location assignment, we can categorize this into two categories where storage yards or warehouses have the input and output points, and products come in and out from this point, or when the products are being reshuffled within the storage yard. So we consider these particular two cases, and I'm going to talk about a little bit more about the crane operated warehouse scheduling problem. And so therefore we introduced this problem, and with some realistic assumptions, and also formalize it in a general manner so that it can become applicable in different industries with similar features with minimum adaptation. This problem usually rises within warehouses which employ gantry cranes, container terminals, and or rail transshipment terminals. So let's look at the problem itself. The storage yard in these problems consist of set of blocks with a capacity of 1, and there is a maximum stacking level defined for them. And the products are coming in from input-output points using the gantry cranes. And these cranes work in parallel together, and each crane can work all along the yard. So, and these cranes cannot pass each other. So they have to respect some safety distance from each other. As you can see in this picture also, these cranes are huge cranes carrying huge products. And and also another thing is that these cranes can move one product at a time. So there are also requests associated with each product, input requests or output requests with due dates. Regarding the decisions in this problem, there are two sets of decisions: location assignment, which assigns location for input requests, and crane scheduling decisions, which focus on assigning cranes to execute requests and sequence requests within this schedule of the certain crane. And so the objective is to minimize both storage costs and tardiness of the requests. So this problem is subject to a set of constraints. First of all, the location assignment constraints, which each input product must be assigned to a location, and each location can store at most one product. These are classic assignment constraints. And then crane assignments, when one crane must be assigned to execute each request, and each crane can handle only one request at a time, as well as some precedence constraints. So another set of interesting constraints within this problem is that conflicting requests must be scheduled for different times. So what are the conflicting requests? Conflicting requests are those requests when we cannot simultaneously, the cranes cannot simultaneously execute the request, otherwise they may violate the safety distance or collide. So looking at this picture, we have this output request of I, when we want to move this product I from inside the yard to the outside, and we have a request J, input request, which wants to move this product from input point to inside the yard. And we have crane CI assigned to request I, and CJ assigned to request J. So looking at this picture, we can easily see that this is if these two cranes want to execute these two requests at the same time, they may collide. So these type of movements should be identified and scheduled for a different time. So this is another example of that. So here, this is a non-conflicting request example where you can see cranes can execute both requests at the same time without any problem. CJ goes to J and CI goes to I. There's enough distance with them and they have different directions. However, if you change the assignment of the cranes, in this picture, you can see, so although physically these two constraints doesn't have any trajectory overlaps, but since we have this CI is on the other side of the yard and request I is the other side, these two cranes, if they want to execute the request, have to cross each other. So these requests are conflicting, and in this case, crane CI must, for instance, if it's the beginner, so CJ should open the way, go away, and let CI does its job, and then afterwards go to the request J. So a solution approach that we proposed for this problem was had three phases. One was constructive phase where we used a greedy dispatching rule heuristic to generate the initial solution, and then pass the initial solution to the improvement phase with late acceptance, hill climbing heuristics, and then at the end of the last phase, the indirect solution was decoded by the decoder and turned into the crane schedules. In terms of the heuristic we use the late acceptance hill climbing, and it's an extension of greedy hill climbing, which compares the candidate solution with a solution which was current L iteration before. This permits worsening solutions and helps to avoid local optimum. So to conduct the computational study, we generated some instances inspired by a real warehouse and also validated by the people from those warehouses. These sets so have four sets of characteristics: number of requests, storage size, maximum level of stacking, and storage load, which indicates how full the yard is. And these testbed have been published and posted online for transparent comparison of our solution approach, and also encouraging other researchers to maybe compete with the proposed solution approach of these work. So we start comparison of the sequential and integrated approaches with using MIG formulations. So the results show that generating better crane schedules by integrated MIG requires more time, and integrated approach compromises in a location assignment to achieve better crane scheduling. However, total evaluation is significantly lower. Also, when the weight of location assignment, we increase the weight of location assignment, the integrated approach may find solutions with 48% in average better crane scheduling, while finding same high quality location assignment solutions. And so this also, the complexity of the instances were growing by the number of requests. We saw that as the number of requests were growing, there were less possibility for the solvers to solve these instances, and there were only 10 of these instances solved to optimality by integrated approach. So then we moved on with a heuristic approach. So the results show that the heuristic approach finds an optimum solution for small instances in a very short time, and actually shorter than the Groovy. And it found 8 optimum solutions out of 10, and however, for those 2, the optimality gap was between 1% to 5%. And so there's another interesting results that we saw, and I wanted to share with you, is that there were instances which sequential heuristic found better solution than optimum obtained by sequential MIP formulation. So here is in this table, you can see this is the MIP formulation, the location assignment evaluation and crane scheduling evaluation. And this is a sequential heuristic, location assignment and crane scheduling, where you can see how sequential heuristic was able to find same quality of location assignments, which enables it to improve the crane scheduling even more than the one with MIP formulation. So here, the ones that the sequential MIP found didn't allow to minimize the crane scheduling more than this. And this is the optimum solution for this instances. And as you can see, there is a huge difference between these two. And so there were multiple instances of this behavior. And also we simulated a real world warehouse, and we saw that there is a 80% potential to improve the storage cost and tardiness. The second thrust of this thesis was sustainable decision making in e-commerce delivery, which we considered mixed fleet vehicle types with using a real world data by introducing e-commerce delivery problem. So in e-commerce delivery problem, there is a depot with set of vehicles, which each vehicles have its own traveling time and energy capacity, and also parcels have delivery window and origin depot and destination location. So in terms of a decision, there are three decisions have to be made, which the first one is assigning parcels to routes, then sequencing the parcels within a route, and then selecting a vehicle to take the route. We defined a quite holistic and comprehensive objective function. So the objective function was to minimize CO2 emissions, both for traveling and stationary of the vehicles, and delivery costs, both labor and vehicle costs, and total distance traveled by all vehicles, and also minimizing the number of vehicles required to satisfy all deliveries. So as I mentioned, we had access to a set of real world instances for analyzing our alternative policies for sustainable decision making in e-commerce delivery. We had the data for 2 to 6 months from 3 main carriers, which was over 1 million parcels with detailed earliest and latest delivery date, origin depot, and delivery address. And also in terms of vehicles, also it was very detailed set. So we had the cost per kilometers, fuel consumption, range, and driver wages. So it enabled us to have a very realistic simulations. Also to analyze our policies, we had to develop some algorithms, and to analysis those algorithms, we use these real world data and select some of them to anonymize and generate 3 instances based on that, and published it also for, again, to encourage other researchers to participate in this line of research and compete with the proposed algorithms. So this 3 sets of instances that we generated was first of all rural instances, small instances from 3 to 6 to 76 parcels. Then we moved to 5 urban instances, which we considered medium-sized instances from 600 to, let's say, almost 900 parcels, and 5 suburban instances, which were ranging from 3,700 to 5,500. And also in terms of vehicle types, we considered diesel, CNG, electric vehicles, and mixed fleet. So we have proposed 3 algorithms to analyze our alternative policies. First one was constructive heuristic based on cheapest insertion, then a genetic algorithm based on BRKGA algorithm, and a rule and recreate local search. Excuse me. So by analyzing these solution methods, results show that the genetic algorithm performs best for academic size instances, and also for handling the mixed fleet and assigning good vehicle types to routes. However, for larger instances, Runa and Recreate is doing better, and cheapest insertion as a constructive heuristic was by far the fastest one. So due to the scaling issues that we had, we were talking about millions of parcels, the constructive algorithm cheapest insertion was the only viable option that we had to use to simulate our real world instances. So in terms of policies that we simulated and analyzed, there were four main sets of policies. Where, the first one was using alternative parcels delivery, using like green vehicles or eco vehicles, with different technologies of like start and stop engines, or CNGs or electric vehicles. So different types of vehicles which are considered as economic. And then analyzing the impact of having collection points instead of having deliveries direct to the homes, and also analyzing the carrier bundling and regional monopolies when the carriers are kind of collaborating with each other to deliver parcels, and also analyzing the impact of delivery times or service time when the driver stops the car and pick up the parcel and puts it to in front of the customer's door. So this is called the service time, and we were analyzing how important is reducing this time or maybe increasing it. So this is a summary of those findings that we had by analyzing the different policies. We found that the regional carrier monopolies do not increase delivery efficiency unless they are in a very low parcel density region. And in terms of delivering parcel to location points, we see that it has a significant impact to reduce emissions and internal costs. And we saw that increasing the bundle deliveries resulted in significant benefits, and also service time has a huge impact on reducing the total cost as we were expecting, because it was shortening the driver's work time. So conclusions or contributions of this thesis in terms of integrated decision making was introducing the crane operated warehouse scheduling problem, and it also introduced the integrated MEP formulation for this with realistic constraints, especially regarding the behavior of the cranes, and developing efficient algorithms to tackle this problem. Actually, a part of this proposed heuristic is now employed by the world's largest steel producer. They're using it in their one of their storage yards, and real-world crane operated simulations show that there is a huge potential for us to minimize the decisions in this warehouses. And also we generated and published this testbed, which enable researchers to work on. They are realistic and validated by the industry. We hope it's useful. And so in terms of sustainable decision making, introducing the e-commerce delivery problem and efficient algorithms to solve this problem with more than 1 million parcels. Also introducing optimization approach that enables this simulations for evaluating different delivery policies, and looking at both cost and ecological impact of them, and eventually providing some insights based on these simulations. So in terms of future work, due to uncertain nature of operations in crane operated warehouses, online scheduling or stochastic online scheduling are important research lines in this area. Also, exact solution approaches to propose efficient lower bound methods is important, and especially with increasing the smart manufacturing and big data distributed optimization approaches with integrated decision making may be interesting also. In terms of e-commerce delivery, considering more realistic modeling definitely is a huge contribution. The energy consumption, the CO2 emissions, or considering the vehicle capacities, and also considering new technologies and innovations into environmental policies may be important. For instance, integrating crowd shipping into policies and considering different policies together. Thank you very much for paying attention.
Thank you, Sam. You may stop sharing the screen. Thank you for the nice presentation. We'll now move to the second part of today's session. So we're going to start with Professor Charles Sock. As I told you before, Sock is a professor and associate dean at College of Business, University of Cincinnati, and he comes from the Department of Operations, Business Analytics, and Information Systems. Professor Charles Sock, thank you very much for the availability and for the time that you took to prepare this discussion, and you may start discussing it with Sam.
Thank you, Bernardo. I just a point of clarification. Sam didn't spend much time talking about the rail crane scheduling problem. I was curious, is that a section of his thesis that I should avoid at this point, or include some questions related to that chapter as well?
No, feel free, because may I answer right now, or I just write down your question and then answer later?
No, you may answer. Let's.
Okay.
You can do it more dynamic.
Yeah, I just wanted to clarify the focus.
Yeah. No. Please feel free to ask questions from any part of the thesis. Just in terms of because of the limited time and similarities of these two yards, I just picked one of them.
Yeah. So that sort of gets to my first question, or maybe really more of a comment about the integrating themes of the thesis. Clearly, the chapters 2 and 3 on the crane scheduling, you can see some obvious overlaps there in terms of the application. The e-commerce last mile delivery problem of the 4th chapter seems a little bit separated from the other two in terms of the application area. I think it would be really good if you could emphasize sort of common algorithmic approaches or common themes across these different problems, so that there's a stronger tie-in across the applications, and that could be either algorithmically in terms of the types of algorithms that you're using, any kind of solution insights from the application of those algorithms, I think would help unify the thesis a bit more. So one of the themes that also comes out in addition to the application areas is this notion of comparing integrated solution approaches to sequential algorithms. So in the presentation, you pointed out that clearly integrated algorithms provide better solutions. So I'm kind of curious, if we already know that, what would you say is the contribution of your research to understanding or expanding the general knowledge about sequential approaches versus integrated approaches? So how does your work contribute to our understanding of those two solution strategies?
Right. So intuitively, maybe we can guess that integrated decision approaches yield better results. But in the multi-objective decision optimization, we may compromise when doing integrated approaches. We may compromise on one objective to gain better results on the other one. So and also there was always this concern with the complexity of integrated approaches. How can we handle the complexity within our algorithms, and see how this can be actually applicable. So what we did, we actually showed that how can we use integrated heuristics by first of all, in one of the experiments, we raised the weight of the location assignment for the integrated solution approaches to in order to kind of mimic the sequential behavior, and we showed that how how integrated approach is enabling to find same quality location assignment by finding better crane scheduling, and this also shows that there's no need to compromise between any of these objectives, and also we saw that even sometimes heuristic sequential heuristic were able to find more, better results than the optimum sequential mathematical formulation.
Mm-hmm. Okay. Yeah, I think that's a very good point. Another point I would suggest you consider thinking about too is identifying scenarios under which sequential decision making is just as good as integrated decision making. I think that's essentially what you were saying there as well. So yeah, okay. So in all of your studies, you're using various meta heuristics, the bias random key genic algorithm, latest acceptance, hill climbing, some simple construction dispatching rules to find upper bounds for these problems, and then to compare the performance of those different heuristics. So I wonder if you could talk about a bit how pure optimization approaches like branch and bound or branch and cut could be used to find upper and lower bounds on particular problem solutions without spending the computational time needed to find the exact optimal solution. Is that often takes, as you saw, I think you reported in some of your slides today, how long it took to do that. But how might you use these, what we think of as pure optimization methods, more as heuristics to find upper and lower bounds?
So yeah, we started some branch and bound approaches for this to find. I didn't report it in the thesis, but we didn't reach to the very satisfying results in that regard. But however, we use those MIP formulation to get the lower bounds, and in terms of smaller instances, we were able to get optimum solutions and to compare the efficiency of the meteoristics against those. However, in the larger instances, because of using the big M's in mathematical formulations, the use of MIP formulation was not really efficient.
I guess what I'm asking is, could you still use those MIP formulations to find upper and lower bounds on the optimal solution?
Yes, we did that actually, and for larger instances, the lower bounds are very poor, and upper bounds are not sometimes achievable.
Okay,
so this is the drawback.
Yeah, you couldn't even find a feasible solution then.
No.
Yeah. Okay.
That's what the reason we use, for instance, dispatching rules, because there was no way other to.
Yeah. Okay. Good.
Because another thing I wanted to add, maybe because we wanted to be have like as realistic instances as well, in order to in addition to our modeling, we wanted to have realistic instances, and those big instances looks like are very huge in terms of computational, and so the MIP formulation were not able to find even its feasible solution.
Yeah. But you have storage issues sometimes as well with those large problems.
Right, right.
It looked like you may have presented some new results on slide 17 that I noticed. Were those results in the thesis, or were those some of the new results that you're referring
Let
to?
me open the slides and see. There's no new results, but yeah, so no, the results are there, and I can,
Okay.
if you want, I can reference the page also. But
it's okay.
actually, yeah, the discussion is there even, so these tables are huge tables. So I picked two rows only to show it, but the tables fully are there, and the discussion also be made is there.
Okay.
I just wanted to maybe emphasize this because I found it interesting to see.
Mm-hmm. Okay. In the Rails scheduling problem, you're comparing the two algorithms, the 2NG and the NGH. Could you talk about the relative strengths of those two algorithms? They're both this biased random key genetic algorithms, but they use different chromosome structures.
Right.
Could you sort of provide some strengths and weaknesses of those two approaches?
Right. So this problem has considers also again a multi-objective decision making. So one objective is to so in this set of terminals, the trains are coming in. It's kind of a hub for containers, just like a airport, passenger airport, where passengers come into the airport and change flights. So there in that terminal, containers are brought to that terminal and they change between the trains. So one important aspect of these is to do it as fast as possible. So make span is very important and relevant in these type of terminals. So one objective was minimizing the make span, and the other objective was to also minimize the containers left on the terminal. So if you don't manage the capacity of the trains, you may end up not being able to put all the containers on the destination, and some containers may remain in the terminal so that the next train maybe go there, or maybe this takes some time to find the same destination. So this is something really terminal managers don't want to see leftovers. So these two different algorithms that you brought up are focusing each one on one of these two aspects. One is focusing on minimizing more, giving the priority to, they both trying to minimize both at the same time, but the first one gives priority to time, the other one gives a priority to kind of storage waste management.
Okay. In the warehouse crane scheduling problem, I'm curious. So the way you have it structured, you structure the problem is that all the requests are either input or output moves. I'm just wondering if you thought about whether there might be potential value in sort of preemptive repositioning or relocation of items within the storage area. Is that something you saw either in your conversations with in practice, or something you thought about algorithmically?
That's very relevant, and especially for output requests. So sometimes output requests are the product is underneath of some other products, and so you need to move the products on top away to find a way from the product underneath. We consider this set of requests as unblocking requests and under the input request, because these requests also require place assignment, because once you pick them up, you need to find a location to put it there. So we refer to them as unblocking requests under kind of under the umbrella of input requests. However, they are already in the storage yard, but since they in terms of decision making, the behavior is similar to the input requests, we kind of categorize it under input requests. So we treat them similar to the input requests, but we consider them, there are in instances so many unblocking requests, and I mentioned that also in the thesis.
Okay. Just curious, why did you decide to use the late acceptance hill climbing algorithm for that problem? Were there other algorithms, heuristics that you also considered, and sort of why you settled on that one?
Well, yeah, there are different approaches. I mean, different variations of hill climbing algorithm to kind of escape the local optima, from simulated annealing to tabu search to late acceptance hill climbing. We find this late acceptance hill climbing especially effective based on what we saw in the literature, especially effective for scheduling problems. And therefore, we picked it as a solution approach.
Okay. So moving on to the e-commerce problem, you did a number of different computational studies there. I'm just curious whether was there one in particular that you found particularly interesting or compelling of the studies that you did there?
Right. Yeah. So we started with the literature. So in the literature, we saw genetic algorithms are very popular among vehicle routing problems. So we developed this genetic algorithm, and it was very efficient also. However, it was good for only small instances, and it took huge amount of time to mature the solution and be able to find a good results. And so then we had this run and recreate heuristic. When the interesting observation that we had, I didn't mention in the slides, but there's something very interesting we saw. So we used this run and recreate heuristic with two different constructive algorithms. One was cheapest insertion, which is kind of a greedy solution, and the other one was one route per parcel, which basically it's the most trivial solution that you can imagine for this vehicle routing problem, to just assign each parcel to one route. So we used this constructive heuristic to feed also the run recreate, and the results was interesting. How cheapest insertion initial solution was stuck in the local optima that run and recreate was not able to escape, and this unbiased, very trivial solution, one route per parcel, was able to find, actually it did the best performance among the other algorithms with a very trivial constructive solution, which we were not expecting such a result. We were expecting to have since we have a good starter with cheapest insertion, we were expecting to see better results. However, we saw that very trivial constructive algorithm were able to get mature and have a yielding better results with run and recreate.
Mm-hmm. Any intuition as why? So you notice you were surprised by how well that worked. Any intuition about why that worked?
Yeah,
I'll say I worked on a similar logistics problem, and we saw a similar behavior in the heuristics that we tried, and so I'm just curious what you.
Yeah, I guess cheapest insertion takes the solution in such a local optima, which is very difficult for run and recreate to kind of escape sometimes, and I can justify it as this. And whereas this the trivial constructive solution approach doesn't do this, and it's not kind of biased. I would maybe we can label that that the cheapest insertion biases the solution so that it's difficult to improve it. However, the other one is not, solution is not biased, and it's easier to improve.
Mm-hmm. Yeah. Okay. Actually, that was those were all the questions that I had, Sam. But
thank you very much.
Nice work. Yeah.
Thank you very much, Charles.
Thank you very much, Professor Charles Sachs. Thank you very much for your intervention. I would now move to Professor Filipe Alvelos. He's an associate professor at the Department of Production Systems at the Engineering School at Minho University. Filipe, the floor is yours. You may ask whatever you want.
I cannot hear you. Okay, yeah.
Filipe, but you could hear me, right?
Yes.
Okay.
Sorry.
I can hear you, but yeah, now I can.
Okay, now.
I forgot to unmute the mic. I'd like to start by complimenting my colleagues of the jury, complimenting Sam Heshmati and the potential audience, and also to acknowledge and thank the invitation to be part of this jury, which is a great pleasure to be here. Well, to be here, it's always a great pleasure. I'm in my room. But if it was any other place, it also would be a great pleasure for sure. And it was very nice to read this thesis of Sam, and I'd like to congratulate him for the work that he has done. He worked on 3 different problems. Well, the first 2, as was discussed before, were more related than the third one. And in the presentation, he only selected one of them to talk of. But for each of these 3 problems, which are relevant in societal terms and also in scientific terms, he derived integer programming models, approximate approaches, apply them in large instances, most of them related with the problems, with the practical problems, and also did a great number of computational tests, which clearly provided the relevant insights for decision making in this type of problems, or decision problems, or optimization problems. I think that the thesis was very nice to read because it was really concise but rigorous, and so when it's like that, it's always good because we have a really understanding of what was done, and that's important. I also like to point out that there are 3 good level publications from the thesis, and I must also congratulate Sam by that, and also the co-authors and supervisors for that work. One thing that I particularly like, and I think it's undoubtedly good practice in this type of thesis, is the description of the contributions of the author of the thesis in the papers, so it is clear what was the work done by the candidate, and that's it. It's a good practice because we really may evaluate what has been done and the quality of the thesis. I will, if you agree, I will start with 2 general questions or comments. And after I will discuss with some more detail some parts of the thesis. These are general questions. Well, when reading a PhD thesis, we always get some ideas of things that could have been done differently or that could have been tried. My idea is just to have the opinion of some, and with a starting point that the work that was done was a really good work, and we cannot do anything. We can't do anything in work like this or in every work. So my first question is about a topic that is present in the 3 problems, which is multi-object optimization. In these 3 problems, multiple objectives are treated with weights. In the first 2, the crane problems, let's call them like that, there are only 2 objectives. In the fourth one, there are 4. In the third one, there are 4 objectives, right? And well, typical from people from multiple objective optimization or decision analysis, there are several ways that we can address this type of issue of having more than one objective. Sam, you opted by using always these weights, but for instance, there are epsilon constraint method and many others, some of them even a little bit out of the paradigm of optimization. there's the Pareto optimality concept that usually is related with this type of approaches and a central issue in this type of approaches. But as far as I understood, you did not follow that line and just used weights. Can you discuss a little bit on this? Why it was so certain for you that you should use weights and just do it like that?
Thank you very much for your nice words, first of all. And then regarding the question, so since we were kind of integrating these objectives into one integrated solution approach, we wanted to first of all impose kind of demonstrate this in the objective function as well, and show how show this weights, and also so we didn't we didn't want to put more emphasis on either one. So therefore, we use this approach to first of all show the weights of the weights in the objective function, and also we did some analysis of the impact of changing these weights, both for railway terminals and also in the warehouses. So we analyzed the impact of how changing this would, especially with our focus was integrating, how these changing this weight may impact the integration. How so because sequential approaches. Yeah, when you use sequential approach, the solution method doesn't have any idea of the second problem. So it's kind of ignorant and blind about the next. Whereas when you are doing it in an integrated way, you have this insight that which may be kind of biased or unfair when we are doing not fair when we are doing comparisons. So we also considered this by increasing the weight of first objective to show that impact also, and then gradually change different weights, because our focus was to show how integration would change, and we show that as well in every range. As we show all ranges of these weights, the integrated decision, the integrated solution falls below the sequential, and however with changing this the gap between sequential and integrated decreases or increases depending to the priority or importance of which decision the manager would want to emphasis on.
Okay. My second question still is a general one, and is about well, in the three chapters, the three core chapters of your thesis, there is something really nice, which is first to present an integer programming model that formalizes the not formalizes but formulates the problem at hand, and then you just say that it's NP hard, and you go to heuristics. What I think it could be, I would say, interesting to think of, and I think I missed a little bit of that when reading these chapters, was some relation between the integer programming models and the heuristics. And we can go with more details later, but my first impression is that you could have somehow try to use the insight of the integer programming that you gained, which it's for sure, at least in some parts, it's for sure related with the heuristics that you later developed, and try to not necessarily mix them in a math heuristic or whatever, but just use the integer programming to guide the development of the heuristics approaches. I don't know if you have something to say about this.
Well, I completely agree with you, and this is what we. I mean, I personally realized more afterwards, after the work was more mature. So I see that I could get some insights and it would be maybe some shortcuts for me to some of the decisions that I'm making in designing the materialistic approach in terms of how to explore the neighborhoods. At first, honestly, I didn't had this kind of view or insight, but gradually I saw it, how this could be useful and how it is important, and I 100% agree with you. And this is a very interesting point, actually.
Okay. So I'll go now for more detailed questions about each of the chapters. And for the first chapter,
hello.
The second chapter, really a difficult problem.
Leap, just repeat the first sentence that you just said now. We missed you for 10 seconds.
Okay, I'll go to the second chapter about the rail transshipment problem, and it's clearly a difficult problem. And I think the model that you were able to develop is a very well, it's difficult to build that model, so it's a good job that you did there. And also it's a nice result to have the ability to solve such large instances for this type of problems with the Bayes random key genetic algorithm. And I would like to well, talking about this integer programming model, the first thing that I noticed is that you have a section 2.3 named continuous time model. And then I was hoping to have a 2.4 section named discrete time model, where you could enjoy the pleasure of formulating a different model for this problem. Do you have any comment on that? Was that?
Yeah, so you know, we were trying to be when formulating this problem to be as realistic as possible. I agree. Sometimes maybe these discrete times formulation may be able to we can solve can be solved easier. We can solve maybe better, larger instances. However, you know, it's kind of approximation, and sometimes in this, the time units that we needed to use for this discretization were so small that made the huge number of decision variables and not worth it to try, because these cranes, as you know, they are moving together, and at every second we need to kind of monitor what they are doing in order to avoid this collision and keep the safety distance. So we had to actually, we thought about it, and we had to kind of discrete the times in so little chunks so that make it more feasible. That then it loses its whole idea of kind of make it a little bit helping to solve, and makes a huge number of decision variables and make it more complex.
Okay. Now, well, you mentioned here on page 12, perhaps it's not necessary to go there, but we can just talk about it. It's the objective is to minimize the total transshipment time. In this case, well, if all the load is loaded, this would correspond to the make span, right?
Right.
Okay. And well, it happens here, and it happens in other parts of the thesis that you mentioned that. Well, sorry, let me go there. You mentioned that the objective is to minimize the total container transshipment time while simultaneously loading as many containers as possible into the trains.
Right.
Well, my question here, and perhaps it's not just a question but a comment, and it appears in all the problems and is related with the multi-objective question, is that I don't think this phrase is totally formally correct, because you are saying that you are trying to minimize two objectives at the same time, and we know they are conflicting. So I think in this type of phrases, you should try to rephrase it in a more rigorous way, in the sense that you cannot do that, minimizing at the same time both objectives.
Right. Right.
At least this is my view on multi-objective, multiple objective optimization, or multi-objective optimization.
Yeah.
And related to that issue of the two objectives, at the first glance, this is a dynamic problem, right? So the containers are arriving, and you are doing the transshipment of them to the other train, and then they are leaving.
Right.
And what you are making is just to select a period of time, and during that period of time, you'll try to compromise between these two objectives.
Right.
Right?
Right, exactly.
What do you think of a conceptually different approach, which I know that it's not, we cannot do anything, everything always, but what do you think of, in this dynamic context, just to have the fixed time, the duration of the slot, and in each slot, you repeat, you solve the problem with a single objective of try to maximize the loading. So the problem will not be with two objectives, it will be with a fixed time. So you will not minimize.
Right.
And does this?
Yeah, it might be. I mean, it is definitely an interesting approach and helping. However, I think you know, because of this whole pressure of the growing within this terminal, the idea is always to minimize that constant time slot, always. So constantly, so this problem is inspired by a real world problem where they really wanted to kind of perhaps wanted to continuously minimize even that time slot. So because as I mentioned, this yards are a little bit like they are actually a hub, and so there are multiple cranes coming in, and they want to do it as soon as possible. But however, I understand your point, and this is something interesting. Yeah, I honestly, I didn't think about it.
Mm-hmm. I don't think you mentioned computational results on this model. Did you implement it and try some for very small instances?
I did, and the reason is that we didn't implement the. I mean, we didn't formalize the buffer line, and for the meta heuristics, we wanted to use the buffer line. So we couldn't kind of make a comparison between these two. So, but however, I implemented that, and I run it for the small instances and saw how it was behaving. However, this is a little bit different from what heuristics are solving, because they are considering the buffer lane where you can send one product to the buffer lane and goes to the other side of the yard. Once you cannot, because assuming that there are three cranes, you cannot pass the container between the cranes, because these cranes in this layout, they don't travel all along the yard. They have their own designated working area, and the working areas have overlaps. So those type of those type of assignments are not feasible for mathematical formulation, as we didn't implement the buffer lane. So the reason you didn't see that is this, that it was not possible to make a comparison.
I was just curious, because for sure it's
it is. Yeah, I did. However, I implemented, and I run it for smaller instances.
Okay. My another question about this this chapter 2 is when you prove that the problem is NP hard, you mentioned the sequential ordering problem.
Right.
And another problem that comes to my mind when reading the description of your work is parallel machine scheduling. So which machine is a crane, and you have the operations that are the tasks. I don't know, perhaps it is related with perspective of looking at the integer programming model and then try to develop some heuristics. but did you thought about it? How did
Yes.
this relation in?
Yes. Yes, actually, we had this comment also from reviewers of our paper, and which is very interesting also. And we definitely considered this, but there is a slight difference between the, for instance, job shop scheduling or other machine scheduling problems and this problem. And that the slight difference is the variable setup times between these two, assuming that the cranes are the machines, you know, assigning different locations for instance, containers, let's say, you are changing the setup to different. So the setup time is kind of variable and it's dynamic changing, whereas in job shop scheduling, you don't see these things. So this is the slight difference between these two. However, they're really similar. And my current actually research is on flow shop scheduling.
Okay. I was not saying that was the same thing, but if you fix the X, Y, W variables, fix those variables, then I think you'll get at least some closely related to parallel machine scheduling.
Right. Agree.
Yeah, okay. I have a question about the choose of the algorithm. Did you, and now going through to the heuristic approach, used two different decoders, and then you compare the results with the dispatch rule?
Right.
What came to my mind was that the dispatch rule could also be a decoder. Does it make any sense?
Dispatch rules also uses decoder within itself.
I was saying inside the genetic algorithm.
Well, yeah, I have used that heuristic within the yes, definitely. Now I see your point. Yes, I have used that within the genetic algorithm, especially when you know. So there are two chromosomes, one focusing on the distance and the other one focusing on the container space.
Okay.
So especially with the when I was working with the distance, I was using this dispatching rules as well inside as a decoder.
Now less theoretical question. What was your experience with iRacer for tuning parameters?
Well, I liked it actually, and I still am using it. And the good thing for that was the first time I was using it, I was not very super familiar or you know experienced. So it was easy to pick up. It was easy to learn. It was easy to implement in terms of implementation. And I figure out the result if you're able to define relevant weights, relevant ranges for iRace. I think you may be able to get a good tunings. And yeah, I had a very good experience, and I liked it. I still am using it, and so.
Can I ask you how long you took to tune the genetic parameters?
It takes a long, especially when you. So I had a set of trainer kind of instances, and you can actually kind of set the number of trains. So I remember I was setting for 2,000, I think maybe runs, and so it took some time. And I had a kind of like 50 maybe or more or less instances for each problem to feed it for a trainer. And I cannot tell right away on top of my head, but it took. I remember it was not easy, you know, to tune. Maybe some hours, like 7-8 hours. I put it there and then came back to get the results.
Thanks. Well, going to the third chapter, where you talk about the crane-operated warehouses and you integrate location assignment and the scheduling of the crane in a single problem. this chapter we see, and you already told us that is related with chapter 2, but well, in the thesis we cannot see, it's not explicit their relation, and I think more than the relation, it could be interesting to see what are the insights that you gain from one problem to the other. I don't know if you want to say something about it. If we see requests and as operations, there are some constraints that are different. For instance, I believe precedences are not present in chapter 2, and there are other differences. But the way you approach the two problems, can you say what was the first that you dealt with, and what do you gain with that you could use, that you used on the second one?
That's a very interesting question. So this the chapter 3, there's a different kind of fundamental difference that makes it a little bit difficult to compare these two works, is the cranes working area and the way they behave among themselves. So this makes it a little bit difficult reusing the thesis, and you know, they're reusing the chapter 1. However, what we learned from mathematical formulation implemented here, and so we used the same thing as a continuous modeling, and we were able to compare this mathematical formulation with our heuristics, and this was the main thing that we took from that part, and yeah, that's it. But I agree. I mean, these are something that we can emphasize more. Probably another reason is that so this paper, this is exactly a paper, published paper, and since the other paper was not published yet, I couldn't kind of reference that. That might be a little bit of a reason, but
okay. Going to the well, not to the choice of the materialistic, but just to comment on that, I think it something that could be a contribution to other people that want to solve this type of problems and use this type of methods, although could not change significantly your results, but something that could be useful for other people was to compare with other methods. Well, I'm not asking you to go through all the meteoristics, sorry, to all the meteoristics or the all possible neighborhood structures or so on, but some when it's easier to implement other things, I think we could do it. We can do it, and it's nice to have some more insight on the behavior of different types of approaches. And I'm specifically thinking of VNS or VND, when you have these all these neighborhood structures that you implemented for the late acceptance hill climbing. You could, it doesn't seem to me that it would be a great effort to implement something related and just to compare and say, well, this is in this problem with these instances, this is better than VNS or whatever other meteoristic. I'm not talking about changing for tabu search or whatever, but when the structure is very similar, I think that's something that we can do when we do this type of work.
That's a nice idea. However, the focus of this chapter is more on the integration rather than the solution method. That was probably one of the reasons that we focused more on you know, emphasizing how to integrate these two decision making, and how is the impact of integration in terms of computational time, in terms of the improvements, rather than you know, emphasizing on the solution approaches. This was the one reason that we used, because of the focus.
Yeah, of course, I understand that perfectly. Related with that, my first comment on using integer programming on the heuristics. In this problem, I think it would be very easy to replace some of the neighborhood structures with integer programming. I don't know if it's too heavy or not, but for instance, the greedy location assignment or the nearest location assignment, when you are just solving some small problems because you are looking to enable a small neighborhood, you can just replace that with integer programming, perhaps. And this is a type of thing that it may make sense on the combination of both approaches. Well, this is just a comment.
I agree with this, and I think that that's very relevant. It's a nice idea. I think, yeah.
Okay. Now I'd like us I'd like to ask you something about page 60. You say that when you equal alpha to beta, and then you say that this putting the same weight gives equal importance to storage and delays. It's not obvious to me that is like that, because at least they have different units, right?
Right. So the storage costs are based on the how the products are located in the warehouse, especially in this specific problem. We were dealing with hot coils, and for instance, the warehouse manager didn't want to locate the hot coils coming out of the production line near to the cold ones, because it was getting hot. Or it can be another application of it would be in aromatic warehouses, when you don't want to put the aromatic products next to each other in order to avoid mix of the fragrance. So therefore, these costs are kind of artificially made. And what we tried to do once designing these costs was to giving more or less similar, so it's the range and making it a little bit normalized and comparable with the scheduling costs. So once we putting alpha and beta equal to each other, these two costs are designed in a way to be normalized, so and comparable.
Okay. Can you just give me some verbal description on the figures 310? In particular, I was a little bit puzzled with the relation of the blue, green, and yellow.
Right.
Can you see that?
Right. Yeah, I have opened it. So you want me to to describe these pictures for you?
How, yeah. At the first glance, the blue and the green should sum up to the yellow, no?
Yeah. So the weights used is half, so it's kind of averaged. Alpha and beta are equal to 0.5.
Okay. So the blue, you have the location assignment problem, the value of that part of the objective function.
Right. And green is scheduling.
Scheduling, and the total is the yellow one.
The yellow one, exactly.
But they don't sum up, because
if you put the average, I mean 0.5. So you know these are actually different values for this. So when it is equal, it is 0.5.
Okay.
When it's beta over alpha is equal to 1, the actual value of beta and alpha we used was 0.5.
Okay.
Okay. Yeah. So that's why when it's 1, beta over alpha is 1. It's exactly the average of these two.
Okay.
It's in the middle.
Okay. And just to finish this weights issue, is in practice, how do this work? So the person in charge for this problem, we just have to give some weights to the two objectives according to the problem that he has. That and
they were not so going into advanced points like this in practice, what they had earlier. So they had a so first of all they didn't kind of they completely had a blind sequential approach using some constraint programming to find feasible place assignments, and then trying to find crane scheduling based on dispatching rule. So basically they didn't have this insight.
Okay. Moving to the chapter 4, because I don't have much time. Okay, this in chapter 4, it's a different type of problem. It's not related with houses or cranes or scheduling. It's related with vehicle routing, and in fact, I think the strong point of this chapter is on the study of the alternative practical policies. In the previous chapter, the strong points are clearly the models and how the problems were solved. And here it's more on the analysis, because the problem is, I would say, quite standard. The instances can be different and the vehicle types can be different, but this is very related to VRP.
Exactly.
And my first question is about why the problem was modeled as an open problem. Why vehicles doesn't return to the depot or go to another location at the end of the day, for instance?
They actually return to the depot.
Okay, so it was my mistake. And that is more general, I think. Okay, so.
Right.
I think that it comes to mind when looking at this problem is the possibility of transshipment, and you work with transshipment on the chapter 2. And of course, we are trying here to solve very large instances because the parcels are small parcels. But do you think you can manage to include here transshipment? Well, perhaps to solve smaller instances.
I didn't exactly understood what is exactly the question.
If you could move some parcel from one vehicle to another.
Right. Okay. Okay.
So you could have some in some points, some hubs, for instance, you could
right.
You could change the parcel.
Right. Well, I think but that's a very interesting and revolutionary, I would say, idea. I think on the other hand, I think depot are already serving at this point where the parsers are coming in from different points and relocated in different kind of vehicles. So we are kind of tackling the second part of it, which is reassigning, this parcels from the depot to the actual destination.
Okay, I understood that you only did 5 runs. Am I correct?
Right.
Do you have any reason for such a low number of runs for this? Well, this is stochastic and so on.
We used that at first. I think I remember we used 10 runs as well. We didn't see much differences, and so we moved on. I mean, the rest of the instances with 5 runs. So I remember doing it at first with 10, and it was taking time. Especially with the genetic algorithm, it took hours sometimes.
Okay.
Yeah.
Well, discussion and insights of subsection 453 are clear and well supporting. I think it's are the main strong and the main contribution of this chapter, as I already did. And I think this problem is interesting because it has some, it can be as a starting point for other optimization problems, from the location of the collection points to relation with crowd shipping that you mentioned also in your presentation. And so I think this is a nice chapter to have more work to do in the future.
Right.
And with that, I will finish my participation in this part of the discussion, and just like to say that it was really a pleasure to read the thesis, and also to congratulate you once again, and wish you a good luck for your future.
Thank you very much for your time.
Thank you very much, Philippe, for the thorough discussion on the thesis. I will now move to Professor Pedro Amorim from the Faculty of Engineering of University of Porto. Pedro, you may start asking questions and discussing the thesis with Sam.
Okay, so let me first start by saying hi to Sam. It's a pleasure to see you again. Let me, of course, also, yeah, of course, also let me compliment the whole jury. It's a great pleasure to be here. I was a few years ago in the pre-defense or the first step of some defense. So it's a great pleasure to come back again and to look to the outcome of the thesis. And I think I'm in general, I agree with the comments of Philip and Charles. So I will, since I don't have as much time, I will move right into the questions. But I think we all agree that you have done a nice piece of work, and the overall thesis is quite interesting. Sam, congratulations. So let me jump, and I will most of the times devote my time to chapter 4. It's the chapter that is also more connected to my research, and I think also that Charles and Philip, they have covered well chapter 2 and 3. But before jumping into chapter 4, I would there's a couple of things I would like to go with you, mainly in terms of understanding some of the sentences that you make, and in particular some bold claims that I believe you make both in introduction and conclusion, that I would like to have your second view on that one. And so in introduction, you mentioned that you contribute both to the theory and to the practice of science, I would say, right? So in your point of view, what exactly, what was your main contribution to the theoretical part, and what is your main contribution then to the practice?
Regarding chapter 4?
So actually, you stated that the introduction, right? So I believe it could be
okay.
Just in general. Yeah,
no, okay. I just wanted to make it clarified.
No, it doesn't have to be in the.
Okay, yeah. So well, thank you for asking this question and bringing this up. This is a very important point, and it's worth it to be emphasized on. If I want to say main contributions, my main theoretical contribution was to first of all kind of introducing these crane scheduling in warehouse scheduling, integrated warehouse scheduling problems to the community, to the academic society, and also considering some realistic constraints within this problem, whereas so far there was no studies considering these dynamic assignment of locations for cranes, and studying and formulating the behavior of the cranes mathematically, and kind of studying it with using some algorithms. So I would say if I want to say one, my theoretical contribution is introducing this, providing a platform for other researchers to work on this by generating this test beds. We had these test beds designed very carefully, and we validate this with the industry so that it makes sense. So we consider different features when generating them. So I think opening this kind of avenue for future research is an interesting contribution, if I want to pick one for my theoretical aspect. And in terms of practical, so as I was explaining to Flip, we were closely in touch with the industry, as even I was sometimes some period of my work I was working one day in their warehouse. So I was closely in touch with them, and they actually didn't use any. So they were using this blind sequential approaches, and getting very low quality solutions, and they were very concerned with this, and they had spending a lot of money and capital on buying it, because they were a big company, the world's largest steel producer, and so they spend a huge ton of money on buying these rail mounted cranes, allocating these storage area, and so they were very interested in having this work optimized, and however, they were not doing it. And as a outcome of these thesis, they are now partially using these algorithms in their. Actually, they are using it. I think it's like 4 or 5 years now in their. Maybe 3 years in their storage yard, and this is also, I think, it's important contribution, because these are big company who are already a frontier in their industry, and using this application and gaining benefits is one thing. And also in terms of e-commerce delivery, also these insights are very useful for any practitioners who are going to manage this type of e-commerce deliveries. And especially so the idea of this thesis, the last work has come from the industry, from the three different carriers, main big carriers. I don't want to name them, but the largest carriers in Northern Europe, 3 of them gathered together to find this, to solve these, had these questions, and they wanted an answer for these questions, kind of. So I think this is also important to mention.
Okay. Thanks a lot for the clarification. And so let me jump into chapter 4, as you were saying, and bringing back Philip words. I think it's really nice to do what you have done, which is to mention what was your contribution in the different parts of the chapters, right? I think this was a collaborative work, which I strongly value, and I think definitely PhDs nowadays they are revested with these cooperation layers that definitely increase the average quality of the work. But nevertheless, I see that the underlying paper of chapter 4 has a lot of co-authors, right? And I would just like to hear your word on, from all the co-authors that work on the paper, how do you distill your contribution? What do you think was really, the innovative ideas that you brought into the table that rendered this an interesting piece of work on chapter 4?
For this chapter, we had, as you said, different co-authors, and my main contribution, first of all, was designing the genetic algorithm, first of all, in terms of solution approach, and also participating in designing the test beds for the designing the test, the whole not coding. I mean designing the how to test this policies. Also, I had the role of kind of taking an academic point of view of this piece of work, because it was very super practical, and I was less involved with the practical terms with the company in this specific one. So my main role was to take an academic version of this work and try to report it. So I did the whole literature review, finding the contributions, our scientific contributions. How can we put this work as a scientific contribution, and then writing the paper, developing the mathematical formulations, and also for the in terms of algorithm design, I completely designed the genetic algorithm. Also helped with ideas on designing the rest of the algorithms, helped with ideas, and then also running the experiments and writing the. So I mean, mainly when I arrived to this project, kind of the practical work a little bit has been done. So I tried to, what I did, try to take a kind of academic perspective to the problem and write it basically.
Okay, and that super connects to one of my comments, Sam, or actually question, because more like a comment, to be honest. Because when I read the introduction and I saw that there was a super extensive piece about the literature review, right? So you actually go through the different problems connected to the e-commerce deliveries. However, there's not a single sentence that connects the work that actually the chapter proposes to that literature. So, you know, for me, when I go through the literature review, I would like to say, you know, paper X and Y that this did that. And so, you know, I'm building on top of this by extending on Z direction, right? So if you could go back now, and since you were involved on the literature review yourself, how do you connect to the literature? How do you think this paper actually extends the literature that is, you know, booming in terms of e-commerce deliveries? Because I think that's something that was not so clear from the show.
Right. So in terms of this, especially green, let's say, vehicle routing problems, there are so many, you know, different ways to categorize the literature. And if I want to say, so the whole literature were based on applying one set of vehicles, let's say electric vehicles, and kind of working with only homogeneous fleet. There were few studies how they used two sets of kind of fleet, and they had this kind of reflected these two in their mathematical formulation. So you couldn't extend it to multiple kind of mixed fleet formulation. So for instance, I mentioned the work of Koch et al. In 2015. So our mathematical formulation is kind of inspired by their work, which their work was only for two type of vehicles, one eco vehicles, one regular vehicles, and we were where we wanted to be have this kind of flexibility of using any types of vehicles. This is one thing. The other thing was what type of objective functions they considered. This is also another way you can kind of categorize the literature. And our the objective function that we considered based on the detailed data that we had enabled us to kind of consider a very comprehensive and detailed objective function. There is another line of research which how do they model the emission in these type of works. But we didn't go so deep in that route. However, our more, I would say, contribution is how to employ multiple fleet, mixed fleet, and using a very comprehensive objective function. Also, one more thing is the data. So mainly the data that have people use are generated data, and such a real world data and insights based on these type of data, I think is extremely valuable and reliable, and kind of something that we really missed in literature. So I think this is another addition.
Okay. Thanks. So let me connect again to Philip's comments. So the main contribution of these papers, as we are using almost a known model and a known solution method, is actually on the managerial insights that you can provide through the paper. In particular, what type of solutions can be more interesting to practice, and you somehow simulate the different scenarios that could be available to practitioners. However, if I put my hat of practitioner, I would be worried about two things on the results that you present. I would like to have your view on that. So the first one, and I'm a very, let's say, proficient practitioner, so I know that since you are using these heuristics that are not probably optimal, the underlying managerial insights can be actually biased, right? Because you are solving very large instances, we don't really have a feeling of the gap. So it could be that actually one solution dominates the other, but in the end, I'm giving the wrong direction to the practitioner just because I was, able to achieve the optimal on the electrical vehicle, but I was not so well on the drop-off points. So how confident are you that this is actually the way to go forward, so that these managerial insights are they should be held in practice, as we don't have actually a provably optimal solution?
I really like this question, and I think the response to this solution relies on the number of instances that we use. So we have a lot of runs and instances, and huge number of parcels that considered under these studies. So I think that would kind of cancel out any stochastic behavior or biased behavior, and to kind of it enables us to get some real trends and extract some real behavior from these, because there's huge amount of data and huge amount of runs. So I would say this kind of cancels out biased and stochastic problems to get some insights hugely. However, there always remains such problems, and yeah, I would say there is, but I would say also because of the data that we had and the amount of the runs and everything, considering it gives a good insight, reliable insights, and something that you can use it.
Okay. So that kind of, I think the underlying assumption is that the errors are randomly, let's say, connected to the different characteristics of the instances, right? So if there is like a structural bias, then it might not be true. Okay, great. So if I connect, I'm still on my practitioner's head, and another concern that I have is that you compare the different solutions that you obtain with the different parameters, being it the different scenarios, by using a cost, this objective function that you have created, right? That
sorry, I had your voice gone a little bit.
Sorry. So I'm saying that you compare the different scenarios by using this objective function that you have created to solve the problem.
Mm-hmm.
Right? However, the different scenarios that you are bringing to the table, they actually require different investments. For example, electrical vehicles versus diesel vehicles, etc. Wouldn't it make more sense to use a kind of a total ownership cost approach, or a net present value approach, but something that would actually, bring the investment also to the table? Because it could be that operationally it's a super solution, but underlying there is an investment that it will take years and years and years to overcome. So I think
right.
What's your view on this?
Right. That's something that we can tell about it, and I agree with you that we didn't consider investments on this, and we mainly focused on long-term, view of this, because the investment may be kind of exhausted a few years after, and we looked at it as a ecological, objective. We looked a little bit with a longer horizon than a regular operational objective horizon. So, but yeah, that's a valid point.
Okay, I think I don't have a lot of time, right, Bernard? But do I?
And you can.
Yeah. Okay, maybe just one last question then, just which I think actually connects more to the timeliness of this research. So I know that we all worried about sustainability. It makes a lot of whole sense. However, when I talk with e-commerce players, and when reading also through the different news that come around about e-commerce delivery players, we see that they are, I think, in an early stage of concern regarding sustainability, because they didn't even break even in operational terms. So most of these players, they are losing money as they are entering the business. In particular, grocery retailers, every time they go into the business of delivering to people's house, you see that it's still not breaking even. So these guys are still losing money. why do you went all the way through the sustainable objective as the main goal to pursue? Do you thought that, you know, it makes sense as a researcher to aim more at the 10-year horizon? Why not to focus on the most, you know, prominent problem that we face nowadays in this business?
Well, first of all, there are huge, as you know, the environmental concerns are rising huge. Let's say not as fast as maybe e-commerce, but it is a fast-growing concern, and also as our motivation, one of the main motivation of this work, these questions mainly came from the practitioners. So came from big players of these you know, these industries, maybe the frontiers. So that's why maybe it looks a little bit ahead of the current you know, status of the industry. But this is what frontiers of the industry are thinking already about it, and it may I would say it's a near future.
Okay, super. I'm happy with that. Thanks a lot, Sam. Thanks a lot.
Thank you very much, Pedro.
Thank you very much, Pedro, for your intervention. Sam, I will now move to an amazing team of supervisors that you have. Actually, I'm not sure if people are aware, but you did part of your work at Porto, then at Porto with Maria Antonia Zefran, and then at Leuven with Grit, and then the last part in Cincinnati, I think, with all of them. So I will move now to Grit, Professor Grit Vandenberg's supervisor of SAM, so that you can make some comments, whatever you feel like.
Okay, thank you for the presentation. I would also like to thank all the people from the jury for the interesting questions. I had many opportunities during the last few years to discuss Sam's work with him, so I have no further questions now. Okay, was the connection all right?
Yeah, we could hear you.
Yes, I just received a phone call. I assumed it was you. Okay, so I have no questions anymore for Sam, which I didn't ask during the previous years. So thank you very much.
Okay. Great, thank you very much. Now I'll move to Professor Maria Antonia Carravilla. Maria Antonia, you are unmute. Perfect. You can speak, please.
First of all, it was a very nice moment to hear from you and to hear your all the remarks and discussions that you had with Sam. And I, as Grit, I didn't ask as many questions as Grit did because lately I didn't see Sam as much. But I have a question about the future. So while you were doing your PhD here at FIOP and mainly at CODES in Leuven, you worked with a team of people, and you shared your work, and besides that, mainly in Leuven, you had access to many practitioners, to many problems, problems in the good side of the problems that we like. Oh, that's a problem. People that are not from our area are always very confused about how happy we are with problems, okay? But those problems that you had access to, what's your life now? What do you think your life, mainly in terms of teamwork and in terms of having access to problems to solve? What I expect you to tell me it's even more problems and interesting problems. But tell us what happens with you.
what's happening to me. So now I'm working in University of Cincinnati with chalk on flow shop scheduling problems. This is my current focus. But there's another, since you mentioned this and brought this up about me, actually, I wanted to add another bullet point to my future work, which is a little bit more personal. And so since you brought this up, I'd like to share it with you, but I decided at the last point, I decided to not put it, maybe discuss it later. So now I can even share it with you. So so I've been always kind of curious, how can I connect like e-commerce logistic management or logistic management operations research with my own personal life? And how can I make this relation? So for instance, you see some researchers or academic people that their work is kind of extension their own life. So a woman working on like women's human rights, it's kind of her work is kind of it's her extension of her life. Or an entrepreneur who is working on entrepreneurship, and he was like doing this since he was young. His research is kind of extension of his life. And I had this also kind of to make a little bit of more sense of these works to my own life as a person, as like, let's say maybe international student, as an immigrant, as an international researcher. How can I connect this? And I kind of search a lot about it, even online, to see what I can find. And I find an interesting talk about from an African-American researcher about it. Actually, he was also working on logistic management, and he was bringing up same kind of concerns and talking about how logistics helped and how logistics is personal for him, as he was describing a situation of a black slave in the slavery era who shipped himself from Virginia to Philadelphia. He put himself in a box and locked it and shipped himself to and using the logistics to kind of gain some freedom. And this African-American researcher was kind of trying to say, I was also trying to find connection between logistics and myself, and how can I find, and I see these stories. Another example, he was saying that he found is, he remember when he was going on Sundays with his grandma to groceries. He was saying that they were trying hard to dress up well, to show that they can kind of afford this grocery to the people around them. And he was saying that his grandma didn't feel, very always stressed, and she was not enjoying this shopping. And whereas nowadays, maybe kind of e-commerce delivery helps these stresses off of some people, minorities or people. So he was saying that he tried to make the connection between himself and the logistic management with these type of stories. And so I put another future work for myself to try to find how can I make it personal, and how can I use it as for myself to make a difference in the world, and basically, yeah, how to use it personally.
Okay, thank you. I wasn't expecting such an answer, but that's why we ask questions, to have answers that we don't expect. Thank you, Sam.
Thank you.
I honestly, I thought that you have prepared this question before the session. Now I'll move to Professor Zé Fernando Oliveira. Please, Zé Fernando.
Thank you very much. You are all, I'm clear and loud. Yeah.
Yes.
First of all, thank you very much to everyone that has joined us in this board for the public defense of SAM. It is always very rewarding to hear all the comments, suggestions, criticisms over the work that we have followed, because we learn a lot with that. And I want to thank deeply to the people that have spent their time reading the thesis, the papers, and now are contributing. And we hope that Sam will take advantage of this for future work. Sometimes not really revisiting the problems. Sometimes what is at stake is the attitude, the methodology, the worries, what we should care about when doing the work. And it's eternal. It does not end here. It's something that it is supposed to be learned in a PhD. This is an art more than a science. Being a PhD holder, you have to be postdoc, in the sense that you have to show that you have some domain about these crafts, about being research. So that was very, very nice to hear all the comments. It was a great opportunity also for you to learn, Sam. Actually, this journey has started 2012 with us. So a long time ago, many years, many places in the world. It was already said, you started in Porto. Actually, not really in the Faculty of Engineering. You started in the Faculty of Economics, then you moved to the Faculty of Engineering, then with Grit in Ghent, and then finally in the United States. So I think that you have already the answer for your question. TSP, the traveling salesman problem, is the problem that fits your life until now. It's hard to contribute in this problem because a lot has been done, a lot of research, a lot of very good results, both theoretical and practical, but it's what fits you until now. Maybe you will settle down a little bit, because this travel, this journey also has a lot of upsides, and we are all very grateful to Grit for having you for that long time in Ghent. It was a great opportunity for you, Sam. It was really a great opportunity, and it's not current. It's not common that people can have this. So we are grateful to Grit, surely, and but at the same time, this was somehow fractional, in the sense that sometimes the work that I've done here does not connect well. Grit made a lot of effort in starting your work in Ghent, using exactly the crane scheduling problem. That was something that we have done here, and so moving for warehouses. So it was intentional. It was very nice from her to doing that. But then you had to solve another problems, and the problems are what they are. What the money for the grants is. That's basically, by the end of the day, what moves our research. And so I think that your thesis also pays, let's say, the price of this traveling along the world. I don't have actually any further question. I just want to wish you all the luck. I want to wish you that you may, you know what people say about being a parent, or being a son. You can only pay to your parents what they've done for you when you have a child and you are a parent also. I think that you will only be able to pay what everyone has done for you during these years. And again, Grit was pivotal in this process. When you have your own PhD students, you take care of them, you nourish them, you make them grow. And then in that moment, maybe you can understand better some of the pains of being fathers and mothers, because only when we are there, we understand a little better what goes on. So Sam, it was a pleasure having you here and having been your supervisor, and with Maria Antonia and Grit, and I wish you all the best for your future life. Okay.
Thank you very much. Thank you very much.
Thank you very much, Zé Fernando. We are now moving to the end. Sam, congratulations up to now. So I will now gently. So actually, this defense is being public. So we have people that have been faithful to us throughout 2 hours, a little bit more than 2 hours. I will now thank all the people that have been watching us, because we're going to now move to a more formal examination period. I will stop now the live stream. I wish you all a nice evening.